This is video number 1 for section 5.7, Basic Definition. This is really a wrap-up section to our work with logarithms. By now, we've worked with that basic log statement many times, log base b of x. And hopefully when you see that, your brain says exponent. That's what this represents, an exponent. What exponent? Well, the exponent you would have to put on top of b in order to end up with x. In other words, it's the power of b that results in x. Well, in this final section, we're going to talk about a new base that we haven't looked at before. We've seen lots of different bases to our logarithms. This particular base is a base that is called e. E is just a number. We use the letter e to represent the number, but e is just a number. Well, what can I tell you about e? It is an irrational number. That means it's a decimal that goes on forever and ever and ever without any sort of repeating pattern. Probably the number that you're familiar with that's kind of like e is pi. Pi is also an irrational number, a decimal number that goes on and on and on. Well, like pi, e also shows up in higher math and science, and often in unexpected ways. An example that some of you might see soon, if you take statistics, you may have heard of before the famous bell curve of statistics. It looks something like this. Well, if you wanted to graph that in your graphing calculator, the equation that you would type in has to do with this strange number e. Well, let me tell you the value of e. E to a few decimal places is approximately 2.718. So just like pi, where people learn and memorize that pi is around 3.14, for e, people learn and memorize e is around 2.718. Now you don't really have to memorize that because you can get it right off of your graphing calculator. So here's the calculator. You can find e in a couple of places. The simplest place is right here in blue above the division sign. That little e, that's our e we're talking about. So if I hit the blue button and then choose that division sign, I get e, hit enter, and it will give me the decimal value. There's that 2.718. You can see it goes well past that. And of course the calculator is cutting it off because this is irrational. It goes on forever. The other place on the calculator where you can find e is right over here, also in blue. Now this is e to the x, meaning you would use this if you want to calculate like e squared or e cubed. If I wanted to do that, I could choose second, hit that button. If I wanted just e by itself, I guess I could type e to the 1, hit enter, and there again is 2.718. So you can always find that value right off your calculator. Well, if you use this weird number e as the base of your logarithm, you get what is called the natural logarithm. Natural logarithm just means log base e of x, where e is this weird 2.718 number. Because this logarithm, this natural logarithm, is used so much in higher math and science, it has its own special abbreviation. The abbreviation is ln of x. You would read that ln of x or natural log of x. And while it may look a little different to you, it's simply a logarithm. Every time you see it, if you wanted to, you could just rewrite it like this. That's all it means, log base e of x. I tend to write the L here with a cursive L, just so that you don't get confused. It is an L, not an I, ln of x. Well, let's try some basic or simple examples using this natural logarithm. Remember, these are just logarithms like every other logarithm that we have met. The first example says, and these are meant to be done by hand, at least at first. The first example says calculate ln of e. Well, one thing you can do to help yourself as we go through this is when you see an ln, just put a tiny e down here in the base position. It's there. We generally don't write it, but it's there. And that enables you to read this in the way you've been reading these since we started, as simply log base e of e. In other words, we're being asked for a power. What power? The power that I would put on top of e in order to end up with e. My base is this little e that I wrote in. My result was given to me. I'm looking for the power. Well, it's a pretty obvious power. It would just be a 1, like we did on the calculator. That would be the answer. ln of e equals 1. Example B. Again, I can write in the little e there in the base position. It's there. Just write it in. This now says log base e of 1. In other words, if I want to do the little scratch work, e to the mystery power equals 1. Well, the only way to turn things into a 1 is to use a 0 power. Natural log of 1 is equal to 0. Letter C, same idea. Let me write in the little base of e. This just says log base e of e to the 7th. In other words, what power would you have to put on top of an e in order to end up with e to the 7th? Well, I think if you write it like that, it's pretty obvious that the answer is a 7. 7 is the power you would have to put on top of an e in order to end up with e to the 7th. Finally, part D, natural log of 30. Well, again, I can fill in the little e. This means what power do I need to put on top of an e in order to end up with 30? Well, this is the first one that I really can't do by hand. I don't know. E is around 2.718. I'm looking for some power that I could raise that base to in order to end up with 30. For this one, I'm going to have to rely on the calculator. So back on the calculator, remember how we found e to the x in blue over here on the left? Well, the main button that goes with is ln, natural log. That's ln, the one we were just using on the handout. If I want to calculate ln of 30, it's very easy. Choose the button, type 30, close the parentheses, hit enter. ln of 30, the natural log of 30, is around 3.401, etc. Remember, all you've just found here is a power. What power? The power you have to stick on top of that e number in order to end up with 30. You could even check it out for yourself by calculating e raised to this power. Back on the calculator, I can go second to choose the e to the power button. And then in this calculator, I have a little power right there for myself. I will type in 3.4011. Now I'm rounding it off. Actually, that means I need to change that last digit to a 2. I've rounded it off to 4 places. I don't expect then that I'll get exactly 30, but I ought to be pretty close. And sure enough, it's right around 30, and that convinces me that I found the right exponent. So back to the handout, the answer to part D was approximately 3.4012, rounded to 4 decimal places. Be on the lookout for rounding instructions as you work these problems. The main thing to keep in mind is that while it does look a little bit funny, it is just a logarithm like any other log. And what's great about that is it means all the same log properties still apply. The switching forms property, for example, still true for natural logs like any other log. The 3 famous rules of logs, still true for natural logs. In our next video, we'll see how you can use some of those properties and rules to solve similar equations to the ones we've already been doing in this chapter. Obviously, this stuff becomes much more useful in later courses. We're just giving you an introduction in this class.